to the Tin Barn. I'm Pragmatic Lee, and today's video is going to deal with cutting dovetails again. I've done several videos lately that involve dovetails, but this one's going to be a little bit different. If you recall, in one of my previous videos not too long ago, I said something about needing one of Randy Richards' dovetail cutters. And shortly after that video, I got in touch with Randy and we exchanged some emails and some communications back and forth. And I got one of his brass scribes, and I also got his large dovetail cutter. Let me grab the other one I was using right quick and show you what I had been dealing with. This is one I've had for a long time, and as you can see, it's actually missing one of the flutes on there, and not very sharp at all. But I got this one, and after again exchanging a few messages with Randy back and forth and letting him know I had got it, and he got a package from me as well, I had another package in the mail from Randy, and didn't quite understand it. I opened it up, and it was one of his small dovetail cutters with the 1/2-inch shaft. I sent him a message, told him I sure appreciated it. He said, well, you might want to thank one of your viewers. Viewer Reed Eichner, E-I-C-H-N-E-R, had seen the last video that I did making dovetails, cutting a dovetail, and contacted Randy and said he wanted to buy a cutter for me, send it to me. So Reed, I greatly appreciate it. It's going to go to use today. The project I'm working on, this one's a little bit big for it. I'm going to turn the camera around and show you what we're going to work on today. Okay, I suspect all of you have seen this method of measuring a dovetail when you're wanting to duplicate one, just as I was doing when I was making these boring bar holders. I wanted to duplicate the female side of the dovetail from this. And again, I think most of you have seen videos where you use a set of pins like that and a adjustable parallel in between to measure that distance and duplicate that on the other side. Well, what I want to do in this project is to take two pieces of steel and put a male on one side. I'll put the male in the thin piece here and a female into this piece. Now this is for another project, another upcoming project, but I don't want to confuse this project with what's coming up. So today we're just going to talk about making the two parts of the dovetails. I decided I would do a prototype just to see if my logic would come out right and what information I could glean. So I took these two aluminum blocks here just to see how close of a dovetail, how close I could come out in there. And I was really pleased with that. What I'm going to do on this, again, is the two steel blocks over here make the two parts of the dovetails, and I'm going to see just how close I can get it, just for practice sake, as I did in this. But then I'm going to come back and make a gib to go in, and at that same time I will take the male piece that we've cut and make it so it's not quite as tight anymore, but that way the gibs can be tightened down. One of the things that in preparing for this, one of the things that I learned was another relationship to the pins. When we use a set of pins to duplicate a dovetail, we usually put them on the inside, and like I say, use a calipers or I like to use an adjustable parallel, wedge that in there, and then use the micrometer. But we always measure on the inside of the two pins. Well, here's another relationship we can look at. let's say we started with a female piece and we just cut it to whatever size. In my case, I'm going to make that center section just so that the smaller dovetail cutter will fit in there, which will be, that'll be a little over an inch, about 1 inch and 16 thousandths on this short point here. But if we put our set of pins in there and we let them hang out to the outside here, let's see if I can get this set up. Now, instead of measuring inside the pins, let's take a measurement right quick to the outside of those pins. Being sure everything's seated down in there good and tight. And that comes out to 1.112. Of course, that will be entirely dependent on what size pins you use. You want a pin that will fit down in that dovetail good, not right on the top edge, but will catch the bottom and the side fine. So we've determined that. Now let's look at the counterpart of this, the male side of it, that I did a little bit by trial and error. But let's take these same pins, put them in there, and again, just to help hold them, use a little toolmaker's clamp. So we've got those in there now. Remember when we had the pins in here, we measured to the outside of them. Now let's measure to the inside of that. There's 1.110, within 2 thousandths, measuring the outside of the pins here and the inside of the pins there. So we're going to use that relationship between the two in making and cutting our steel blocks. I'm going to cut the female first in here, and again, I'm going to cut it just the center, just wide enough for this to go into, and then we'll start working each side back and forth until we've got what looks like a good looking dovetail. We don't necessarily want these edges right here to come out to a point. We want just a little bit of flat in there. So I'm going to get this block set up on the mill and we'll take up over there. Okay, I'm in the mill now. Got the thick piece, which again I'm going to use for the female side. I've got it mounted in the mill vise. I've got a stop over here, so that will make centering up the other piece easier. Or if I have to take this out for whatever reason, it'll be easy to repeat it. But I've located the center on the x-axis. I'm using a 7/16 end mill because I'm pretty sure that's about the sharpest one I've got. We're going to cut through this, and I'm going to go a depth of 300 thousandths. I've got the DRO zeroed out now, or zeroed it out, and I'm going to start taking some passes across here. All right, here's our 300 thousandths. Now I'm going to start stepping over from side to side. Remember, we want 1.016 out of that center there to give clearance for the dovetail cutter. So I'm just going to start stepping side to side. All right, we're going to get a little measurement now. All right, I originally wrote down here that we needed to go 0.289 on each side of 0, and as measurement now says 0.288 is what we got to each side of 0. So we got a little ways left to go. A couple more cuts. And remember, if this is a little bit large, it's not a big deal at all, because we're making the male and the female piece, and we're not necessarily making this to match the prototype. We just built a prototype to prove our in-head theory. One 1.01014. That needs, let's see what it looks like. Yeah, that'll clear. All right, I'm gonna get the dovetail cutter set up in there, and I'll bring you right back. I brought the camera around in front of the mill now so that you can see what we've got. We've got a 300 thousandths deep trough cut through here, 1.016 or 1.015, thereabouts. Enough clearance for the dovetail cutter to come through there. What I'm going to do, just like I did cutting this slot through here, is step over to each side from center. We've got the DRO back on 0 now. And I'm not going to step over any particular amount, but I want to step over until I got a good dovetail, good looking dovetail in there, and I've left just a little bit of a shoulder up here at the top. So I'm going to make a couple passes, try to make a couple passes with the camera sitting here, and then I'll move it back out of the way. But for right now, let's just step over about 50 thousandths. I'm turning this dovetail cutter in the high range of my mill. I have 3 options: 600 RPMs, 1120, and 1700. I'm going with 1120. I'm going to see how that does. And I've got it, the depth set so that it just touches the bottom. This is not going to be much depth at all right here. Now we'll step 25 or 50 thousandths on the other side of 0. All right, let's take a little more this time. We're at 50 on the DRO. Well, I tell you what, let's take another 50 and go to 100 on the DRO and take a look at it. All right, since it's so much easier for me to see what the cut is starting at this end, I'm simply going to come back and make another pass on this side, stepping over. And I'm just going to advance 25 thousandths this time, see what it looks like. All right, let's go about 30. Same thing on the other side of 0. In my case, 130 thousandths. All right. I'm going to get this piece deburred now, cleaned up a little bit, and then we'll take some pin measurements on it. All right, I put the pins in this piece and got the adjustable parallel in there to hold the pins tight. I've measured across here with the micrometers and come up with 1.115, and I'm just going to make that notation over on my notepad. I'm going to see if I can get this in close enough that you can see maybe what that dovetail looks like. Not sure it's going to focus. But you can see I left a little bit of a shoulder right up here on these edges. So what I've also done is come to this side over here and measured that long point over here. Now that is not an accurate way to try to cut a dovetail. Trust me, you might get lucky, but for the most part, well, the only true way to cut a dovetail is to use the pin method. But to get this closely roughed out, I've measured across here. I come to 1.225. I subtracted that off of my diameter of this piece, which was 1.837. Come up with 612, divided that in half. For 306 off of each side. So I'm going to take 306 off of this side and 306 off of this side. And then we'll put the dovetail cutter back in and start making our male side. So right now, actually the dovetail's still in there, but there's no need of putting any additional cutting pressure on the dovetail than we have to, so we'll put the end mill back in. And by the way, I don't know if you could tell, if you could see it that well or not. See if I can get it to focus. This dovetail cutter is putting out chips, not just a mush like that old dull one I was using was doing. This is actually putting out full chips on there. So I'm extremely pleased with it. Reed, I thank you again for it. Randy, you did an excellent job on that. And we'll put it back to use again in just a moment. And again, I put me a couple just little sanity marks on there. I'm going to zero out there. And we want 300 thousandths depth. And what we want to do is step that over. Since I'm actually going to be taking this out, I don't care if I mar that up just a little bit, but I'm going to ease it into it to where it just touches, and then I'll zero out the DRO there. And we said we want to come in 306 thousandths. All right, I'm going to do that same thing to the other side, then I'll bring you back. All right, I've got the shoulder cut on both sides now. Got it deburred, and I've recentered and zeroed out my DRO. I've centered on this boss that we have up here now, not the whole piece, but on the boss. Should be the same center because we took 306 thousandths off of each side, but just to be sure, I've zeroed out on the center here. Now, just like cutting the female side of the dovetail, we're going to take some off of each side. Let's see, I want to be sure I'm conventional milling. So I'm going to set right here before I get into the depth on the x-axis and get my Z set. There we go. Now I'm going to just come in and touch off for what I think is a good amount to cut with. And that says 50 thousandths on the DRO. Now I'll go to the same DRO reading on the other side of 0. All right, I think that's maybe deep enough now to get the pins in. Just want to be absolutely certain there's no chips in there. I need to do a little deburring right here on this end. I'll bring you back. All right, I've got the pins in there. The dovetail is deep enough for the pins to go in. And this measures, there's really no room right here to get the adjustable parallels in, so I'm going to simply hold that snug in there and tighten them down. And that is 1.147. We said we wanted 1.115. So that's 32 thousandths left to go. Divide that by 2. That's 16 thousandths more on each side. Now, obviously, I've got the other piece of this right here with me, and I can measure it. But I wanted to show you this using the pins part of it. In case you needed to match up a male-female dovetail that you didn't have a sample to go by, you had one or the other, and the one that you had was not in a position where you could bring it over to the mill and test fit and those kind of things. So, all right, we need to come in 15 more thousandths on each side, 16 more thousandths. All right, I should have that set now. Everything is counting down on each side, so I wanted to check some math on there. Let's give this a try. Of course, keep in mind, for it to fit, it's got to be just a little bit smaller, a couple thousand smaller If it's the same size, obviously it's not going in there. All right. 1.115. So it's probably not going to quite go in there. May have to file just a little bit, or maybe just run a cleanup with the dovetail cutter. But let's see. Look at there. There you go. There's a matching dovetail.